The cosmic code and overture to mathematical magic, mathematics. For some, the word conjures images of dusty textbooks and baffling symbols, but I invite you to look again to see mathematics not as a chore but as a language. It's the language the universe speaks. It's a way to decode the cosmos, to understand its deepest secrets, its most elegant designs. From the spiral arms of galaxies to the delicate patterns of a snowflake, mathematics provides the framework. It's a golden key, unlocking doors to realities we can barely imagine, revealing an underlying order in a seemingly chaotic existence. This universe of ours, it's filled with breathtaking phenomena, exploding stars, swirling nebulae, the silent dance of planets, and underpinning all this grandeur, mathematics. It's the bedrock of our understanding. It allows us to predict, to explore, to comprehend the vastness of space and the intricacies of time. Without it, we'd be adrift in a sea of observations, unable to connect the dots. Mathematics gives us the power to see the unseen, to touch the intangible. It's a journey of discovery, and its paths are paved with numbers and equations, each a signpost to greater knowledge. Prepare to explore this marvel, to understand why it captivates the minds of so many, and how it reflects something profound about the very fabric of reality itself. So, what is this celebrated equation? It's written as e to the power of I times pi, plus 1 equals 0. Just look at it. 5 of the most significant numbers in all of mathematics, all there together in one elegant, concise statement. There's e, the base of natural logarithms, a number intimately tied to growth and change. There's e, the imaginary unit, the square root of -1, a gateway to the world of complex numbers. Then we have p, the ratio of a circle's circumference to its diameter, a constant that whispers of cycles and rotations. And of course the fundamental numbers one, the multiplicative identity, and 0, the additive identity. Many mathematicians and physicists have called Euler's identity the most beautiful equation in mathematics. Why such high praise? Its beauty lies in its astonishing simplicity and its profound depth. It connects these 5 fundamental constants, each from seemingly disparate branches of mathematics, arithmetic, algebra, trigonometry, and analysis, into a single harmonious relationship. This unexpected connection is what elevates it beyond a mere formula. It becomes a piece of mathematical art, a true masterpiece of logic and structure. Let's delve into the first character in our equation, the number. Its value is approximately 2.71828, and like pi, it's an irrational number, meaning its decimal representation goes on forever without repeating. But he is not just some random string of digits. It's a fundamental constant that appears naturally in processes involving continuous growth or decay. Think of a population of bacteria doubling at regular intervals, or the way money grows with continuously compounded interest. E is the base rate of that natural, smooth, uninterrupted growth. Imagine you have £1 and a bank offers you 100% interest per year. If compounded continuously every instant, that's where he emerges. Your £1 would grow to pounds, approximately 2.72 pounds, in 1 year. This constant underpins exponential functions, which describe phenomena ranging from radioactive decay to the cooling of an object, or even the curve of a hanging chain. It's a number deeply embedded in the fabric of natural processes, a signature of how things change over time. So when you see in Euler's identity, remember it represents this powerful concept of natural, continuous change. Next up in our cast of mathematical superstars is the number I. This one can seem a bit strange at first. I is defined as the square root of -1. Now you might think, hold on, isn't that impossible? Any real number when squared gives a positive result. And you'd be right within the realm of real numbers. But mathematics is all about expanding our horizons, pushing boundaries. The introduction of I did just that. It opened up an entirely new dimension of numbers, the complex numbers. These are numbers that have a real part and an imaginary part, like a plus by. The term imaginary is a bit of a historical misnomer, perhaps unfortunately chosen, as these numbers are incredibly useful and very real in their applications. They weren't just invented for fun, they arose from the need to solve certain algebraic equations, like x squared plus 1 equals 0, which have no solutions among the real numbers. Mathematicians like Girolamo Cardano in the 16th century stumbled upon them, initially treating them with suspicion. It was Euler again who did much to legitimize and popularize their use, giving us the notation E. Section 5. Pi's enduring mystery. The circle's constant companion. And now we meet pi. Pi. Perhaps the most famous and beloved number in all of mathematics. Everyone knows pi, right? It's that never-ending number, approximately 3.14159, that you learn about in school when you study circles. Specifically, pi is defined as the ratio of a circle's circumference, the distance around it to its diameter, the distance across it through the center. No matter how big or small the circle, this ratio is always the same. Always. That constancy is part of its magic, a universal truth embedded in the very nature of circular forms. Like pi is an irrational number. Its decimal digits stretch on infinitely without any repeating pattern. People have been fascinated by pi for millennia. Ancient Babylonians and Egyptians had approximations for it. Archimedes, the great Greek mathematician, devised ingenious methods to calculate it with increasing accuracy. The quest to compute more digits of pi continues even today, with supercomputers pushing the boundary into trillions of digits. Section 6, 0 and 1, the unsung heroes of arithmetic. Now we turn to the seemingly simpler members of Euler's identity, the numbers 1 and 0. They might appear ordinary, perhaps even mundane compared to the exotic e and pi. But don't be fooled. 0 and 1 are the absolute bedrock of our entire number system, the foundational pillars upon which all of arithmetic and mathematics are built. Without them, the very concept of counting, of quantity, of existence and non-existence in a mathematical sense would crumble. They are truly fundamental, each playing a unique and crucial role. Let's consider one. It's the concept of unity, of a single entity. It's the multiplicative identity, meaning any number multiplied by 1 remains unchanged. X times 1 equals x. This property makes it a cornerstone in algebraic structures and number theory. It represents the beginning of counting, the first step beyond nothingness. It signifies wholeness, completeness, a single defined unit. In Euler's identity, the +1 term is what brings the EEIP part of the equation into a relationship with 0. It's the crucial element that balances the equation, the piece that completes the puzzle. Section 7, the unlikely trinity, how E, I, and pi converge. We've met the stars, E, the champion of growth, E, the key to imaginary realms, and pi, the master of circles. How do these three constants come together in E-IP to equal -1? The secret lies in Euler's formula E(ix) equals cos x plus I sin x. This equation connects exponential functions with trigonometry through imaginary numbers. A6 changes, E(ix) traces out a circle of radius 1. Setting x equals pi, we get EIP equals cos p plus I sin p. Section 8, a universal language, Euler's identity in science and engineering. Euler's identity isn't just a pretty face in the world of pure mathematics. Its underlying principles, particularly those embodied in Euler's formula, Ex equals cos x plus I sin x, are incredibly powerful and find widespread application in numerous fields of science and engineering. This is where the abstract beauty translates into tangible, real-world utility. It's a testament to the fact that the elegant structures discovered in mathematics often provide the perfect language to describe the workings of the physical universe. It's a tool that helps us build and understand the modern world. Consider electrical engineering. The analysis of alternating current AC circuits, which power our homes and industries, relies heavily on complex numbers and Euler's formula. Voltages and currents that oscillate like waves can be represented much more conveniently using complex exponentials, like EIOT, than with sines and cosines alone. This simplifies calculations involving phase shifts and impedances, making the design and analysis of electrical systems far more manageable. So, the very electricity flowing through your devices is understood and engineered using these mathematical concepts. Section 9 echoes in the cosmos, the equation's grand narrative. Euler's identity, EIP plus 1 equals 0, connects 5 fundamental numbers. It whispers something profound about the universe. It suggests an underlying order, a deep interconnectedness. Numbers representing growth, cycles, the imaginary, unity, and nothingness are linked by this elegant equation, a logic that mathematics helps us unveil. Think about the journey this equation takes us on. It starts with E, the essence of natural processes, ventures into the complex plane with I, incorporates pi, the soul of circles and cycles, arrives at the simplest concepts of -1 and then 0, a narrative of transformation and resolution, This mirrors many processes in nature. The universe is not just a random collection of stuff,